Hello, I'm Mark, and welcome to my Unreal Engine tutorials on how to add support for wheeled vehicles into your physics movement component. So this is a continuation of the wheeled friction subsection, I guess. Yeah, I suppose we can call it that. And in this video, so in the last video, we went ahead and created all the simulation structures and components and then tied it into our vehicle movement traits. So in this video, we're going to take all of that work that we created and integrate that into our vehicle simulation component so that we can both start and move and stop our vehicle and see it drive around the desert floor. So as always, we've got a lot of ground to cover today, so let's get started. Okay, so getting started, we're now in the vehicle simulation component. There's a couple of things I'd like to do to kind of, as part of the setup for this. First off, what I'd like to do is I'm going to bring in another enumerator. Yep, I love enumerators. If you guys can't tell. So this is going to be the wheel brake input, and that's because we have two types of, we have three brake inputs we're going to take. We're going to take the pedal brake, we have the ratcheted handbrake, and then we also have the parking brake. So I'm going to use I'm going to put the pedal brake and the ratcheted parking brake in the same functions, and I'm just going to use an enumerator to determine which value is going to be coming through and map that correctly. So that's there. Next up, I am going to change the this macro here. So this is an Unreal Engine macro for C++, and there's actually two types. There's the generated body and there's the generated U-class body. I'm switching this over because I want to use a different constructor, but also if you're looking to want to add network replication or network replication notifiers into a component like this, you're going to need to use the generated U-class body, and this actually, because this will also bring in other implementation other implementation functions up here in the header, based on what it sees down here. So if you set a property to replicate, it will then bring in an additional function, again hidden unfortunately, but it will bring in other functions that will handle replication notifies, or replication and rep notifies. So that's why I'm going to switch this over. We're not going to do anything with it as far as replication, because that's all being handled through the phys move if we want to network this. But if you wanted to add additional networking things for state-based configuration, it's there prepped for you. All right, so next up, I am going to go ahead and, while we're in the header file, we don't need to add any new physics setup. We already created the wheel setup when we did the suspension, so we're good there. We already have our collision container for our collision tracing, but since we're adding three new inputs, let's go ahead and add the input rate controls for that. So I'm just going to go bring those over, and actually we have three new inputs, but we only need these. We only need rate configuration for two of them, since the other one's a boolean. It's either going to be on or off. We only really need, this is rate configurations for brake and handbrake. And again, this is just going to adjust any latent effects that we want to add into the controller to kind of, change the characteristics a bit of how that input is getting set. So again, we've got a lot of these input rate configuration structs. We're just going to add two more to the mix. And that's going to be for handbrakes, and for the ratcheted handbrake, and for the wheel brake input. All right, so moving down the stack, I'm just taking a look. I'm going to add a new function called destroy instance wheels. And I am going to put that under, where is it, create wheel setup. So because we are working with classes up here, so as you can see up here we have the wheel instance, we may need to, on a reset, go ahead and destroy them in order to be able to rebuild them again. So I've just got something in here, and there could be some additional logic that we need to execute as we flag them for collection in the Unreal Engine garbage collector. So that's what can be done here, and we'll tie this in to the implementation when we get to the implementation start. But that's the new function that we're going to be adding. I'm just going to go ahead and just fix that real quick, and we'll hop on back. All right. Next up, we don't need anything on wheel state. We've already got suspension forces, so we have one more function to add, and that is going to be our apply wheel friction forces. So I'm just going to go grab this. So this is going to be the function where we'll be taking. This is the one which starts tying everything all together as far as being able to move our vehicle, forward, back. So we've done suspension. Now we've finally got to apply wheel friction forces. And I'm just going to go down. I don't think we need anything else. So we are going to need some input functions for brakes. So let's get that. So let me see if I can find that real quick. Here it is. I'm just going to park it underneath the steering. So we have set wheel brake input, and then there's the enumerator to tell switch type. And I'm just going to go fix this real quick. And this one too. There it is. And then finally, let's get those raw inputs in. So we have transmission, shift up, shift down. We have engine throttle input. So let's get this. So we have, I'm just going to bring these in. I'm just going to add this there. So we have, this is the wheel brake, this is the pedal brake, this is the ratcheted handbrake, and then this is the parking brake. Again, this is a Boolean, and by default, I'm going to be setting the parking brake to false. All right, so that's everything I think we need here. Let's just go ahead and just fix this green squiggly, and then I think we can move over into the implementation and go ahead and fill this in. Actually, before we get started, I notice I'm missing a function that we should have added when we were doing the suspension, so I'm just going to add that right in. One of the things, because we're doing a constraint override in the suspension, we need to add another override function on, which is the onDestroy physics state. So I'm just going to add that in real quick. So we're able to create suspension system. It'll go ahead and build everything up. But if the physics state gets reset, it's going to do a destroy first, and then it's going to do a rebuild. We want to make sure that there are some things that we need to handle on the rebuild. All right, so we'll go ahead and add the onDestroy physics state as well. So again, I'm just going to, this is a virtual override function. It's already there as part of the actual, component class. So we'll just go ahead and tap right into that function there. And I'm just going to add it under stop movement mode immediately. So just kind of tie that up a little, tie that off. All right, so first up, I'm going to bring in a new constructor. And I'm also, in that constructor, I'm going to set some defaults to our collision response. So this is vehicle simulation component. Just make sure that's all spelled correctly. So this is a different constructor that is used, and it's used when we are switching over to the generate U body class. So if you're using this, we need to have this constructor defined here. So it's just one of the functions. So we've got that defined, and in here I'm just going to set the collision responses. So we want to get the default container, and then in the default container under vehicle, I'm just going to tell it to automatically ignore those collision responses. So we'll automatically get that set up for us. So just a little bit of housekeeping there on the collision side. we don't need to worry about the initialized network physics. I think we're okay on begin play. Simulate physics tick, nothing new here. That really hasn't changed since we've been doing vehicle, the vehicle stuff, with the exception of adding the wheel state updates. Stop movement mode immediately. We added this at the beginning of the wheels simulation, so that's all the clearing the inputs. So this is the destroy physics state, and the reason why I wanted to bring this in, because we also have the destroy wheel instance state as well. Since it's all kind of used on the physics as part of the physics state. So to do that, I'm going to bring this in, put a big D there. All right, so we have our new function, which is destroy wheel instances. So we want to destroy the wheels first, and then what we're going to then do, since we have these constraints, right? So as part of the suspension system, if we want to use Unreal Engine's suspension constraints, which are built into its physics engine, we need to go ahead and remove them if the physics state is being destroyed. So, and that's kind of what this is doing. It's going to go in, it's going to destroy all of the constraints in here, and by destroying them, and then it'll clear out our, the array, and then we can then rebuild them when we restart when we recreate the physics state. We'll go ahead and rebuild all of these. All right, so, and then again, it's just a simple, we're just iterating through the constraints, and then we just execute the phys command execute, which puts a lock around the physics interface and release constraint. So what we're doing is we're just taking a lock, putting a lock around this guy, telling it to release, and then once it's done, we'll unlock it so that anything else that's going to be going in is going to be we'll be able to, we don't have this. By doing this, we just make sure that we ensure that two threads aren't going to write to the same piece of data at the same time. And that's all that is. And then on destroy physics state, again, we want to put this at the bottom because we want to make sure this executes before it goes and does anything else. Again, order of operation. So on begin, usually you run super first. Okay, execute anything here and then add onto it. Usually on destroy, we're going in the opposite direction. So we're going to say destroy our stuff first and then move up to the super and then tell it to just start destroying its stuff in that operation. So that's that. All right, so then destroy instance wheels. I'm just going to go grab this over here. So again, as part of that, let me just go and change this to what we're using. So as part of this, right, we're going to destroy the wheels first. So what we're going to do is we're going to iterate through the wheels, and we're going to tell it, we're going to issue the shutdown. On shutdown, if there's anything that we're holding on to, this can be very useful if you're using unmanaged memory. So Unreal Engine has its own memory management system that it uses with the U objects, but if we're dimensioning any kind of object that is outside of the its memory management system, which is not using U objects, then we need to make sure that we we dispose of those objects. So we can do that in the shutdown before we the shutdown on the wheel, and that can be done there. And that's an overridden function too. So whenever if the memory table, if Unreal Engine's memory table goes and decides to flag something for deletion, it will also execute shutdown as well on that object before it deletes it. So that way you can release any unmanaged memory objects within there. All right, and then again, instance wheel reset. All this does is it just wipes out the array. And by wiping out the array, Unreal Engine's memory table will say, okay, collect everything in this array. So it'll take care of that for us. All right, let's go down. Let's see, update wheel state GT is next. So here we've got, yep, we've got some more code to add down here. So as you can see, it's kind of getting a little big. So underneath wheel, steering wheel, I'm just going to go add the brake code. So all this is this just taking the simulation wheel brake inputs. It's going to take the raw and the and the wheel brake input that's already in that, and it's going to do its interpol, and then we're going to do an interpolated value based on the float up, float down, which is all part of that code. And we'll do the same thing for the handbrakes. Again, we're just going to do an interpolated value, date, time, simulation, handbrake. And that's for the ratcheted handbrake, not for the parking brake. So the parking brake is a boolean, so we're going to check to see if the parking brake is not on, right? So if this is false, then input simulation enabled raw parking brake is and then it's going to set it to false. So again, we're checking to see if this is false, because this will get reset on the other side once it's being consumed. So we just want to make sure that we're not, we only need to update this as we need to update it. And then we have clear raw inputs. So here's our clear raw wheel inputs. Let's go ahead and get that done real quick. So I'm just going to go ahead and add this is the wheel brake, the handbrake, and I'm just going to bring over the parking brake. All right, so that's the raw inputs. Update simulation. Let's just go ahead and add our final function in here, which is the apply wheel friction. So as you can see here, we've been adding a lot of apply forces. So this is going to be where we apply our wheel friction forces. I'm going to skip over wheel friction forces real quick so that we can just kind of get all of the other smaller functions out of the way, and then we'll come back to the wheel friction, which is kind of where we want to be. So on a wheel brake input, I'm just going to go grab our switch. So again, this is going to be taking in the double value, and it's going to, based on what we set, is it going to be a brake or a handbrake? It'll set each of those accordingly. And then we've got the parking brake right there. Just close that real quick. Close that. All right, so that's everything we need. So now let's just turn our attention to the apply wheel friction. So on each iteration within the physics loop, on physics tick, we're going to be assessing the input values and applying the necessary input values that we need to our friction forces on our tires. All right, and to do that, I am just going to start to grab. We're going to need to do an iterator, and within that iterator, we're going to need to make sure that we've got our wheels. So everything here is actually being an iterator on an object. So because we're doing an iterator on the object, I need to make sure that that instance in this array is actually a valid instance and not a null pointer. So it's going to iterate through and do a cast, and I just want to double check to make sure that that's a perfectly valid object in the array. So next, we are going to do we're going to take a look at the hit result. So when we were doing our suspension forces, right? Actually, before we do the suspension forces, we do our update GT. Let me come up here. I can probably just minimize that. Update wheel state PT. Calculate the suspension tracing. So this is where we actually do the suspension tracing, and we put it into this trace parameters, right? And so these are the results of what our raycast is. So when we fire our raycast, we want to see if our raycast is hitting the ground. If our raycast is hitting the ground, then we want, this is where we'll then because we are setting the value or ensuring the value is being set here to return physics material, and the physics material is actually, you can actually set your physics material here. So if I come back to the editor, right, and you go to physics engine, and at the bottom you've got this physics surface. As you can see, I don't really have anything here, but you can actually define map up to 62 materials, material surfaces, right? And here, and this is, and when we hit the raycast, it'll go ahead and detect which one of these it is, and it will bring that information back up. So this is how you can then set different friction forces for different surface materials. You could also use this if you want to have different sound effects as you cross over different materials, or different visual effects. You know, if a bullet's hitting wood, right, it's gonna, you want to have splinters, and it's going to sound differently than a bullet hitting metal, which would then spark, versus hitting concrete, right? So this is kind of where you could set that up based on that collision trace, and that can all be done on a trace. Let's see, I want this one. By setting the return physics material. So by default, this is turned off. So you'll need to make sure you turn it on before you can actually use it in the trace algorithm. So, and that's kind of why we do that here in the trace parameters. So that little detour is over. Let's get back to our physics, applying our physics. So that's kind of what we're doing, and we store that in the wheel state on the suspension trace results by index. So again, everything, we are doing a lot of index mapping here in order to make sure we get the right wheels, right information for each wheel. So as we iterate through the wheel, each wheel has its own index. We've set that up, and that will tell it where in the array to go to find the information that it needs for that wheel. So there's the hit result right there. So then next, we're going to do another if statement. And this one's going to have an else. All right, so we have wheel physics. So again, here's the profile. This is in contact. So the suspension system is going to tell us whether the wheel is in contact with the ground or not. And so that's when we come to the friction forces, we need to know whether the wheel is in contact, whether, you know, so that we can run the simulation code or not. If we're not in contact with the surface, then we run to the else statement. And all we're going to do is we're just going to tell the wheel profile, wheel profile, which is our struct, set the ground speed to 0, because that wheel is effectively has no ground speed at this point. And set the wheel loading force to 0, because it's not propping up the vehicle at all. And then set the simulated date, simulated delta time. So we'll simulate it. We still need to run the simulation, but we're going to be running it with 0 ground speed and with 0 load on it. And again, it's also be looking at some of the in contact as well within there as well. Otherwise, if we are in contact, we need to make some external calculations based on the tracing coming back, so that we can go ahead and get this wheel, moving. So first off, what did we hit? So again, here's hit result, physics material. So if that is turned on, when we come to physics material, we'll see if we have a valid physics material. So if we're colliding with a material that has not been registered and mapped in here, right, then what it will do is it can either default back to here, which is the default, or it just won't go, it'll just won't register at all. But it should just default it back to the default. And so there's always a default which Unreal Engine's already set, and then everything else is up to us. And again, I'll probably, if anyone's interested, there are a lot of videos on how to set this up through other people, and I'll probably get to something in the future. I'm planning a video on how to set this up as well. So we'll get to that. But for now, hit result, physics, wheel profile, surface friction. So if we have this, we want to get the friction value, which is part of the physics material. So again, all materials. If it's we can set a friction value, and this is the friction value that we're going to be looking for. And this is when setting this up, you want to treat this as a constant, and that's why I have an additive process there, because not every wheel is going to have the same friction curve, friction rate between the material, right? So we can kind of set that up. So that's the surface friction profile going in based on the wheel friction, based on the material friction going in. So that's all gets set there. And we can go ahead and look at the definition for that. So that's just setting that up, and then we just go calculate it when we're ready to run the simulation. All right, next is going to be our steer angle. So we need to figure it. So we're not just in here, we're not just applying, when we're applying the wheel friction, we've got to figure out if this wheel is steering, if this wheel is pivoting, right? Which direction is it going, because that's where the friction's got to go in that angular direction. So we need to make sure that we account for that. So I'm just going to put that in. So again, get the steering angle. So we actually have that steering angle set per wheel in the simulation, because based on whether it's an inside wheel or an outside wheel, or if it's a wheel on a single wheel on an axle versus a pair of wheels on an axle, that could have a very different angle per wheel. So again, we figure that all out. We're going to bring the steering angle back, and then what we're going to do is we're going to go create a rotator, and we want to make sure we put the rotator in the right place. So rotators, just going to go do that real quick. So you got pitch, yaw, and roll. So steering is on the yaw. Pitch is rotating the wheel going forward and back. So that's how we're going to do rolling. That's how we're going to move it. We're going to pitch the wheel over. Yawing is steering. And then rolling is kind of, if you have a vehicle with an unstable wheel, I guess you could put some roll in there. But, we don't have any roll. So all of our wheels are upright. So that's the steering angle. And then from there, we are going to then calculate the steer local wheel velocity. So what we're going to do is we're going to take we're going to go through here and we're going to use the unrotated vector function, which is on the F rotator. And this is where we will take the local wheel velocity at the index. So again, all of these are going to be mapped to the index mapping, and this local wheel velocity again is being set on each tick, and that is again being done as a reminder. Let's remind ourselves that is being done up here on the wheel state PT. So we're coming down here. Actually, no, it's being done before. Actually, no, it should be done here. Yeah. There it is. Update wheel state PT for that wheel. And so this is being done per wheel. So we go into the simulation state. There's the wheel state, update state wheel. And that's when we put the index in and we get the position. And then that's being updated per wheel. And that's being done on the physics thread. And this all gets done before we even come down to applying it. So again, we're now getting that data right, and we're going to do we're going to do the unrotated vector on the steering position to get this local steering wheel velocity. Okay, and next. So from there, we're going to set the ground speed based on the based on the local wheel velocity, and that again, that's the rotated. So it will be the ground speed rotated in the direction that we need it to go in, and then from there we can actually then run the simulation. All right, so we're going to go ahead and run the simulation, and again we're running a simulation on each wheel because each wheel can have a very different outcome based on the values coming in. And then after the simulation is run, we then are going to say get the force from friction. So this is now getting the friction force. We're then going to take that friction force and then we're going to run it through our rotator to make sure we get the friction force going in the right direction. So if this is a wheel that is steering, we want to make sure we're applying that friction force in the right direction, and that's what's going to help us steer and turn. All right. Then we've got some additional work here on the ground vector. So this is our ground vector, so we're going to be doing some additional calculations. So again, we need the ground z, which is our normal. So that's where we're, that's based on the normal flat of how we're touching. So if it's a flat surface, the normal will always be up. But if we're going up a hill or we're going down a hill, that normal position is going to be changing based on the direction that we're, where that tire is, or at the time that we hit that normal. So then we're going to take the state, right axis, and ground z vector, and that's going to get us our ground x vector, right? And then we're going to do another cross product on the ground z vector and the ground x vector to get our y vector. So this is now the this is the force at the position based on the normal in the direction that we actually want the vehicle going. So if the vehicle is going uphill, we want to make sure that force is going to be going uphill instead of into the hill, right? And it's the same if we're going downhill and we put a braking force, we want to make sure that force is going correctly in the right direction that we want. All right, so from that, finally, we're going to come down here, and we're then going to go and get a matrix. So we're going to take the x vector, y vector, the z vector, right? So that's going to go into our matrix, and then we're going to get the transform get location. So again, this is coming from the vehicle state, and again, we're always calculating the transform, the location of the vehicle. Right, so we want the location of the vehicle, and this is the force in relationship to the relationship to the vehicle, and then we want the world transform. So this is the position in the world. Once we have the matrix, then we're going to get the transform vector. We'll take the friction force against the matrix that we've created here, and then that should get us the final friction force vector. And then once we have all that, we can finally, if this is a wheel that is in contact with the ground, we can take that friction force, and then we want to take the impact point. So this force, and this is the force based on the vehicle's position, the direction, the rotation of the wheel, as well as the normal, whether it's going uphill, downhill, or on the side of the hill, right? We got to make sure all of that force is being rotated into the right direction at that impact point, so that we can then go ahead and place it. And we're placing it at the impact point, and that's the impact point of the trace algorithm. So that's the raycast. So that force will be applied there. So again, if we've got wheels on one side that are in contact and the other wheels aren't, then one set's going to be moving and the other, and that could again the physics system will add rotation and torsion around the physics particle based on that. So that's what that's doing, force at position. All right. So, and again, we need to do all of that if our wheels are in contact. If our wheels are not in contact with the road, then we don't need with the ground. Then we don't need to do any of this at all. And at that point, we're just a free spinning wheel, and that's what's going on down there. All right, so that should do it for apply wheel friction forces. So I think we should have everything that we need in here to be able to go back into the solution and see if we can get our vehicle to move. So can see there's a lot of things here, and there's a lot of stuff which is kind of intertwined. So to try and tease this out is a little bit challenging. But I think we have it all. All right, so let's go ahead, go into the solution, compile this, and let's see what we've got. So I'm just going to bring this up. Let's close this down. Okay, so let's just check to see if we've got a good compile. So I'm just going to run this. All right, cool. Good compile. All right, so everything should be set up. So now I think we're ready to go into our content drawer and go and make the final setups on our vehicle wheels. And then we should be able to see if our vehicle is going to move across the desert floor. All right, so let's go into the content drawer. So back when we did suspension, we went ahead and created our wheel blueprints. So we can now come into our wheel blueprints. So I'm just going to move this back onto screen. So there's the front wheel. So we just did a simple front wheel and rear wheel. So we're going to have 4 front wheels and 4 rear wheels. And so with our front wheels, we're going to make sure that steering is enabled. We have some new values in here. So we have max torque, brake torque, as well as the handbrake torque. We have brake enabled versus handbrake enabled. So if you want to turn that on, if you want to add that in, we can. Or you can keep it turned off. It's up to you. We have the wheel surface multiplier, as well as the friction force, as well as cornering stiffness. We have a lateral slip graph. If you want to, so again, you can either use this value or this value, and then we have a multiplier based on the scale of the graph. Side slip modifier, thresholds, as well as all this other stuff. And then this is all the stuff that we already set up when we did the suspension. So we've got a pretty springy suspension system down here. So I'm just going to go ahead and minimize suspension. We don't need to worry about the offset. So again, the offset, this is only really needed when if we're using a vehicle where we may not have control of the root bone. So again, with the vigilant stuff, all the root bones are on the bottom, so we need to make sure that we offset everything by the root bone in order to get a nice vehicle simulation there and make sure our suspension trace roots are hitting in the right place. All right, so let's get these wheels finally configured. So you know, I'm going to use the same value for both of these. I'm going to use, so handbrake's going to be 2000 and pedal brake's going to be the same. Actually, you know what, I'm going to make this up maybe a little bit stiffer maybe for fun. Wheel setup, that's fine. Let's see. Well, we can turn handbrake enable on, why not? Steering, that's fine. This is the front wheels, so front wheels are going to have steering, the back wheels are not. We have wheel surface material multiplier. That is going to be set to 1, and the friction is going to be set to 3. So that should give us plenty of friction on those tires to move us across the surface. As far as cornering stiffness, I'm just going to go ahead and just use a cornering stiffness. I found this value works really well. So this is going at 7.5 and 4 zeros. Again, I'm sure there's probably a multiplier that we could be putting in there. Remember, Unreal Engine works in centimeters, so everything is a unit of a centimeter. So if you think that these numbers are really big, well, yeah, they're just not scaled. Yeah, they're just in centimeters, so where most things should be in meters. All right, so let's see. As far as the slip, skid, and max threshold, I'm just going to set this, since we got some big wheels, I'm going to set those to some big numbers there, to 100. And I think that should set up the front wheel. And let's go to the rear wheel, and I'm just going to do the same. Let's just do the same for the rear wheel. The only difference here is that the rear wheel doesn't have any steering, so And we're going to set that to 3. Again, cornering stiffness. I'm going to give it the same. So again, this is cornering stiffness on each wheel. So because that's where we're calculating all of the forces are on each wheel of the vehicle. So that's why we need to make sure that this is here. And this will be applied to every single wheel, which is a rear wheel. So if you wanted to have the front wheels to be stiffer than the back, you could just change, you know, the value on the front to the back or the back to the front. Again, you've got customization there. I'm going to set that to 3. We don't need to do anything on the suspension, and I'm going to set this to 100. Copy 100 and 100. All right, so that should be everything for wheels. Let's go back to the blueprints, and let's see what we've got. Vehicle, we have. All right, we have all of our wheels, and we've got them mapped to all of our bones. And again, we actually set up the bone maps when we were doing the vehicle setup. So again, we can come under Striker. So what we have is we have our own animation blueprint. We just copied that. We just took a duplicate of that. We went and just re-blueprinted that to our physics vehicle animation instance. So we created a custom animation instance, which is now integrated with our components. So it's when it starts piping in the wheel data, it'll pipe it into a nice little map for us to then collect it, and then we have this nice little function here which we can then pull both this value and this value and just park those into these bone modifiers. And again, on location, we're just doing an add to existing. That's going to get our suspension. And then rotation now is going to be where we can see the steering as well as the pivoting, right? Oh, the rotating, I should say, of the tires. And that, again, that's just add to existence, you know, existing. And that's all done through that. All right, so as far as inputs are concerned, we have the throttle. So we created the wheel brakes. So let's go ahead and hook that up now that we've got the function for it. So I'm just going to pull this off here and just say set. So set wheel brake input. I'm just going to do just the wheel brakes. If you guys want to play with it on the other settings, you can. So that's that. So that should be everything we need to do the wheel brake. So we have the accelerator, which is on engine simulation, and we have the wheel brakes. We have the ability to do paddle shifting on the gear shift, and then we have our steering, which is coming off the yaw input. So we're just repurposing. Here I'm just repurposing the throttle input X and the yaw input. All right, so if we've done everything correctly, we should be able to see our vehicle in the desert standing on its wheels, and then if we apply the controller, we should start seeing it rolling. All right, so I'm just going to go ahead and move this off screen real quick, and let's go ahead and pull up the desert map. So let's see, where do we put that? Wide open spaces. So let's open this puppy up. Alright, so there's our vehicle right there. Alright, so let's give this a whirl. See if we've hooked everything up. So I've got my controller turned on. Controls turned on. Let's hit the play button. There's our vehicle bouncing around, so suspension is working. Gonna hit the trigger. We're not moving. Let's put it in gear. Alright, so there we go. And now we're moving and we're turning. Yeah, okay. I think we're missing a piece. I think we have the accelerator stuff done, but I think we need to go back into the code and add the brake inputs on the physics thread. This, we'll head back over to C++, and let's get those braking inputs in real quick. So let's go bring up the code. Let's see. Where do we park those? We have update state PT. Yeah, here we are. So we have new inputs. Yeah, here's the hole right here. So, we haven't touched this in a long time, but this is where we've got the inputs for the transmission, and this is where we have the steering wheel here, and we have the throttle. So now we just need to add the braking inputs. So we've set that up on the GT, piping those in, but we're not applying those to the simulation. So let's go ahead and just do that real quick. So we have the engine braking, so that's all good. And that's already there for us, but again, it's not being applied because we still don't have some pieces here. So let's go ahead and do that real quick. So I'm just going to go ahead and add some if statements. So this is our pedal brake. So if brake enabled, so this is our profile. If brake enabled on the wheel profile, we need to be able to set this. So again, and this is checking to see if this wheel has a set of brakes on there. So this isn't saying, are we braking? This is, does this wheel support wheel braking? That way, because you could have some wheels on a vehicle that don't have any brakes at all, and they're just free wheels. So if you wanted to have that, you just turn that off, and any input going in, we would just ignore it. But all of our wheels do have pedal brakes, so let's go ahead and set that up. Again, you could have wheels that just have parking brakes and don't have pedal brakes, right? The parking brake's either on or it's off, and you don't have pedal brakes on there. You can you might see that in like aircraft if you wanted to do undercarriage, the wheels of an aircraft. So you could turn parking brake, braking enabled off, but parking brakes on, and you could get that. So wheel profile. So here again, we're going to take the wheel brake input. We're going to multiply that by the max brake torque. So that's in the profile. So that's a value that we have. And so we're going to take this, multiply that by the amount of torque, and that's going to tell us how much force. So if we're putting a little bit of braking in there, we don't want to take the full torque, we'll take a percentage of it. But that's what's then going to go into braking forces. And then with braking forces, we're going to got this nice big long function here. Well, let me see if I can just boost this up a little bit for you guys. And I'll just take that out. So again, here we've got our braking forces, engine braking. We have so there's our braking input, max brake torque, and that's kind of in our blueprint. So what we're going to then do is once we have this on the profile, we're going to set the brake torque. So this needs to be fed into our simulation. And I'm actually going to be using this Newton meters to centimeters. So we created this function when we were working on our utilities. So this is how we want to go and scale the braking forces. So we're going to take the braking forces here. So that's going to be scaling that from from the meters that we're calculating on the max brake torque here, and we're going to scale that into centimeters, which is what Unreal Engine prefers, so that we can actually get the actual amount of braking force. So braking force, engine braking force. So from here, we're going to take so set braking force here. So as you can see, we've got the value, and then is engine braking available. So what we're going to then take is the engine braking. So if this is a powered wheel, right, we only put engine braking on engines that are engine enabled, right? If this is a wheel that it does not have power, then we don't bother. So we need to check to see if so this is where we say engine braking force is greater than the braking force. If that's the case, then we'll be using the braking force. Otherwise, if we're not, we're just going to use the engine braking instead. We're not applying the brakes, but if we're not applying the accelerator, then the vehicle will naturally want to slow down eventually based on the engine. All right, so that is for if if brakes are enabled. If this is a wheel which doesn't have any pedal brakes, then all we're going to do is we're just going to take the engine braking. So again, there's still power to this engine, right? If there's power in this engine, so that's why we got this engine braking is set to 0 up here. So if this is a wheel that has power but it doesn't necessarily have any brakes, we just want the engine braking, and we'll set that to true. And again, we would take meters and convert that to centimeters. All right, so that should do it for pedal brakes. But if we have parking brakes and handbrakes, right, then I'm going to go ahead and add this setup down here. So again, this is our simulation inputs. So if we have handbrake, so we're going to check for this, and handbrake is enabled, right? So this is the simulation input, and this is the value. So if these are both true, so we've applied this and our wheel supports it, we will execute the parking brake over the handbrake torque. All right, we'll figure this out. Otherwise, if we are, if wheels parking brake enabled, right? So again, this is our parking brake. So if handbrake, parking brake. So if parking brake is enabled, but the handbrake is not enabled, okay. So it's a little confusing. So we'll take either one of these, and then we'll determine whether we want to take the value in the parking brake enabled versus handbrake torque versus the parking brake torque. Okay, and this is just an inline if statement. So we're taking a look at this, and if it's parking brake, we'll take the handbrake torque as is. Otherwise, if it's not parking brake but it is a handbrake, then we will take this multiplied by the torque. So this is the input times torque. So we only want a percentage of this torque based on how much of that handbrake we've applied. And then you've got your wheel profile set brake torque here. Again, just like up here, again, Newton meters to centimeters, and then we just take the brake force. All right, so now that we've added that in there, we should be able to recompile this and see our vehicle stopping as well as starting. So I'm just going to go ahead and minimize this. I'm going to come back here and do a compile real quick. Okay, so let's do a compile. Okay, good compile. Check to see my controls on. It is still on. And let's go ahead and hit the play button. All right, so there is our vehicle bouncing around. I'm just going to click on here. I'm going to put it in gear. And there we go. Our vehicle is now rolling and turning. And now we can slam the brakes on, and it slows down and stops. And then we can start it back up. And as you can see, I've got the debugging on, so you can see the ray tracing going into the ground per wheel. So as you can see, it's got 4 wheels or 8 wheels, so we've got 8 traces going as we kind of move along the ground. All right, so I'm just going to hit the stop button. All right, so I think this is going to do it for wheeled vehicles. And I think this is also going to do it for my physics system. I think we've come a long way. We've got a lot of good things in here. I've certainly enjoyed doing this video. I hope you guys have as well. And I hope you guys have learned a lot of great stuff, because I know I have in building this. So yeah, as always, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel. And yeah, I'll see you again in the next video. Cheers, and have a great rest of your day.